The title of my presentation today is The Production of a Dried Avocado Powder. My name is Saheeda Mujaffar, and this work on avocados was part of an MSc research project by Ms. Tsai-Ann Dipnarine at the Food Science and Technology Unit at the Department of Chemical Engineering. Avocados are enjoyed by many around the world, and the flesh is used in the fresh form as well as in various culinary applications such as guacamole, smoothies, and avocado butter, and also used for the extraction of avocado oil, which is used for cooking healthy and flavorful meals. The Pollock avocado seen here is a West Indian type of avocado that is very popular in the region. It is oblong to pear-shaped and can be very large. The skin of the fruit is smooth, green, and glossy. The flesh is thick and smooth and contains less fat than many other avocado varieties. And when fully ripe, the fruit is described as creamy and buttery with a slightly sweet and earthy flavor. Once cut, however, the pulp undergoes rapid discoloration, and avocados generally require treatments to maintain color to an oxidative process which is catalyzed by an enzyme called polyphenol oxidase, and which results in the development of dark polymers. Treatments to maintain the original color of the avocado pulp can include citric acid, ascorbic acid, sodium bisulfite, and TBHQ, just to name a few. Traditional drying methods for fruits usually involve placing the fruit in a stream of hot air to produce a convenient shelf-stable product. Avocado pulp, however, tends to become discolored, shriveled, tough, and rubbery, and develop bitter tastes upon thermal processing. Because of these complications, freeze-drying is being investigated as an alternative method to produce a high-quality avocado powder, but there are only a few reported works on this drying technique. Now, for this drying technique, the material to be dried is first frozen. Then the material is placed under vacuum, during which water is removed by sublimation, that is, from the frozen state or ice directly to a water vapor, and this water vapor is then removed at low temperature. No works have been reported on the freeze-drying of Pollock avocado except for previous work by the present authors. And in that study, freeze-dried slices were fully dried and with good rehydration characteristics. You see here the fresh slices, the frozen slices here, which shows that the avocado slices can be frozen and maintain high quality. And this photo here is showing the freeze-dried slices, which you can see that they maintain the original structure and the color is also maintained. So further work was needed, however, based on some observations that were noted in this study. For example, the formation of ice crystals on the surface of the slices due to any water that might have been present, partial thawing of slices prior to drying, and a slight bitter taste after drying, which may have had to do with temperature control. The objective of this work, therefore, was to investigate the drying of mashed avocado pulp using two methods: the traditional hot air or oven drying at 60 degrees and vacuum freeze drying. The pulp was prepared by simply peeling and mashing the avocado pulp and then placing the pulp into Petri dishes at a fixed depth. Samples to be oven dried were placed immediately into a cabinet oven set at 60 degrees and left for 24 hours. Samples to be freeze dried were first frozen for 72 hours in a walk-in freezer, then placed in a vacuum freeze drying unit and left to dry for 72 hours. All samples were dried until constant weight was achieved. Samples were dried until constant weight and then analyzed. The rehydration behavior was assessed and the drying curves generated from the weight data that was collected during the drying run. Let's take a quick look at some of the results. Compared with the oven-dried cakes, which you see here, the freeze-dried cake, we call it's called a cake because it looks like a patty and it's dried. So the freeze-dried cakes were superior in appearance with an attractive yellow-green color, similar to that of the fresh samples, just a bit lighter. The oven-dried samples darkened severely, as you can see here, and they also became quite hard and crisp at some points and suffered severe shrinkage. The yield of the freeze-dried powder averaged 17.1%, was higher than for the oven-dried samples, and the moisture content of the freeze-dried samples was also significantly lower at 2.06% wet basis. Freeze-dried powders were also less dense than the oven-dried powders, as you can see from this chart here. With respect to the color attributes of the samples, freeze-dried powders were closer in color to the fresh puree as indicated by a lower color difference of 29.4. In terms of rehydration, freeze-dried powders, you see here, rehydrated rapidly within 10 seconds or so of mixing to produce a thick paste with a puree-like consistency and a vibrant green color. Oven-dried powders required longer stirring time of about up to a minute or so, but the hard granular pieces failed to fully rehydrate, producing a chunky, granular, dark green paste, as you can see here. With respect to the drying behavior, drying was found to occur in the falling rate period, and this is depicted in this chart here of drying rate versus the average moisture content. And this means that the process was controlled by internal moisture diffusion. That is, there was no surface moisture on the samples, and diffusion was the rate limiting factor here. The Verma model was found to best fit the moisture ratio as shown in this curve here, and these are the constants for that fit. With respect to the storage of the dried powders over a 12-week period, there was a slight visible darkening of the powders as storage time increased, and the powders also appeared, and this is the lightness factor here, the L star value. Also, there was a loss of green color here from the start of the trial to week 12. There was a corresponding increase in moisture content over the 12-week period as well, and a color change over the storage time. This highlights the need for proper packaging and storage conditions for this product. This is a snapshot of some of the main references. And just to note that work is continuing on this topic with respect to the packaging of powders, as well as the manipulation of the operating temperature and pressure in an attempt to reduce any traces of bitter bitterness in the samples. So at this point, I'd like to say thank you. And should you have any questions, feel free to email me and I'll be happy to chat about this work. Thank you very much.